Okay, good morning everyone. We're going to do 5.3 today, solving trigonometric equations. Okay, and to start off, I actually want to look at the idea of how many angles have the sine of 1/2. Okay, so for this chapter, you'll want your unit circle and your identities page. So first, looking at a unit circle, where cosine is 1/2. Well, we know it goes cosine sine. So cosine is 1/2 at 60. It's also 1/2 at 300 degrees. So 60 degrees and 300 degrees. But are those the only two? Well, if you think about it, we've got infinitely many coterminal angles at 60 degrees and infinitely coterminal angles at 300 degrees. Remember, coterminal are angles that end in the same position. Or, if you think about it, if we had a graph of cosine, if you remember, cosine starts high at 1, and then pi halves, pi, 3 pi halves, 2 pi, and it just repeats this pattern over, that's not good, over and over again. So if we looked at where it's 1/2, and we drew that line in, and this goes forever, technically we have all these infinite solutions. So we said 60, we said 300. Okay, if it's coterminal, what's another one? Well, 300 plus 360, so that's 660 degrees. 60 plus 360, so 420. Okay, so this could go forever, and you guys can't see that. Okay, so when we look at solutions for trigonometric equations, we have to be careful. If it says to find them all, we actually technically have to list them all. So I could have said this is 60 plus 2 pi n. Okay, so n being any integer, and then 2 pi because it takes it to go all the way around to get it. So probably, since instead of doing 2 pi, since I'm dealing with the degrees, I do 360 degrees n. Okay. So what we're going to do in this section, and a lot of this chapter, if it says solving, it's either going to give us a very specific area to solve, or we're going to have to solve for all of them. Okay, so let's go ahead and look at, this is example A. Find all real numbers, we're going to do radians, that satisfy each equation. And my equation got erased. Okay, so that satisfies each equation. And I'm just going to look something real quick. Okay, so I've had books use N, H, and different letters. I just want to make sure your book does use N. Okay, so we kind of already solved this one. Cosine theta equals 1/2. So we found on our unit circle where it's 1/2 with 60 degrees, or pi thirds, since we're going to do in radians, and 300 degrees, 5 pi thirds. So we've got pi thirds and 5 pi thirds. Okay, so if we want to find all of them, is there a way to get from 60 to 300 in an even count, like by 180 or 360? Okay, sometimes you could go 180 and you find your next answer. In this case we don't. So our answer is going to be pi thirds plus 2 pi n and 5 pi thirds plus 2 pi n. Those are going to be my two solutions. Okay, again, identifying, hey, this is where it is on a normal 0 to 360. And if I was to continue around or continue on my graph forever, in either direction, then I would have infinite solutions. Okay, so then let's look at this one. Sine theta equals negative square root 3 over 2. If we look at our unit circle, where is sine, our y value, negative square root 3 over 2? So sine is negative. All students take calculus, so it's going to be these two. Negative square root 3 over 2. We have at 4 pi thirds and 5 pi thirds. So 4 pi thirds and 5 pi thirds. So to get these coterminal angles, I'm going to have to go all the way around. Same with these. So my answer is going to be 4 pi thirds. 4 pi thirds plus 2 pi n, and 5 pi thirds plus 2 pi n. So this 5 pi thirds is true for both cosine theta is a half and sine theta is negative square root 3 over 2. It's the same position, same angle. Okay, so tangent, square root 3 over 2. Okay, if I look at my unit circle, I actually don't have the tangents on this unit circle, but we know tangent is sine over cosine. Okay, so sine over cosine. So if I looked at pi 6, that's 1/2 divided by square root 3 over 2. So that's 1/2 times 2 over square root 3. So that's 1 over square root 3, which is square root 3 over 3. Okay. If we look at 45 degrees, that's square root 2 over 2 divided by square root 2 over 2, which is just 1. And then if we look at 60 degrees, okay, so this is 30 degrees, 45 degrees. So this is square root 3 over 2 divided by 1/2. So that's square root 3 over 2 times 2 over 1, which is square root 3. Okay? So I'm just going to write that on my paper. So this one was square root 3. Oh, you cannot see that. This one was square root 3 over 3, 1, and square root 3. Okay. So where we want is tangent is square root 3 over 3. So that was my pi 6. And so there's my 1 positive. So I'm looking for another one that has square root 3 over 3. So that would be all students take. So in quadrant 3 it's going to be positive. And if we look at that, that is going to be the 210 degrees, or 7 pi 6. So those are my two angles, pi 6 and 7 pi 6. And if you notice on this, pi 6 and 7 pi 6, it takes 180 degrees to land on those. Okay, so I actually have to write one answer. I could say pi 6 plus pi n, where I add 180 degrees, and that's going to land on all of my answers, which kind of makes sense, because if you remember in the graphs, tangents period was pi, while cosine and sine were 2 pi. So we should be able to get back to where we started every 180 degrees. Okay? So then last one on this video. So if we look at the negative one, well, we said 45 was 1, and everything is positive here. Tangent is going to be negative in quadrants 2 and 4, which is going to be our 3 pi fourths and 7 pi fourths. But again, because of that 180 period for tangent, we could just put 3 pi fourths plus pi n. Okay, so that's our first video. I have several of them, so yeah, watch the next one.